All right, guys, we are on section 2.4
Yep.
and moving along. This is kind of a, I don't know, a little different section. We're just talking about a bunch of rules, really.
Yep.
They're called postulates. We've used that term before. And again, a postulate is it's kind of like a definition in a way. It's something we just accept to be true. We don't have to go through and prove it, and we really haven't gotten to proofs yet, but still, we don't have to go through and prove it and so on. We just accept these things to be true.
And we're going to use them to say things like, because we know this, we can say this.
Right.
And so that's kind of that whole thing of the deductive reasoning we've been talking about, to where if this happens, then we can assume that this is going to happen.
Mm-hmm.
And so that's what we're going to use these postulates for, guys, is to create really logical arguments.
Right.
You know, and to be able to solve problems involving geometry ideas.
Yeah, these are going to be kind of the building blocks of a little bit more complicated things later.
Right.
And so again, we just have to assume that these are true to be able to build on top of them.
And you don't really necessarily have to remember their exact, like this is postulate 5, this is postulate 6.
Yeah.
You just got to remember the ideas behind it.
Yeah, and really we don't want you to call it like postulate 5,
Yeah.
8 or whatever. We just want you to know the concept behind it. So,
Yep.
So let's dig into them. We've kind of already talked about this one in
Yeah.
the first section when we were defining points and lines and so on. But through any 2 points, you draw a point on your paper, 2 points on your paper anywhere, or even three-dimensionally, take 2 points anywhere, and there's always exactly one line. And when something says exactly, that means there's not 0 lines, that means there's not 2 lines, or 3 lines, or any other number. There's exactly one line through any of those 2 points. And again, you think about that, you can't draw like a curved thing through those because that's not a line. So if we look at 2 points, and there's only one line that goes through those. So that's what that postulate says. And again, sometimes I think students look at these like, well, duh.
Right.
And that's kind of the way they're supposed to be, because again, they're things that we don't have to prove.
Right.
We just accept them to be true.
Mr. Christopher, how many lines could you draw through 1 point?
That would be an infinite number, right?
So make sure you guys remember
Because you
that.
could spin it in any angle,
Right.
and it would be an infinite number through 1.
Yeah.
But as soon as you put that other one in there, then you've picked an angle, and it has to be drawn that way.
That's right.
So
Pretty easy one to remember, guys. Just through 2 points, there's only one line.
Yep. And then a line is at least 2 points. Now again, we talked about the concept of a line being an infinite number of points. So, but we always have at least 2 points to make up a line. And so the diagram really is the same thing. But at least a line always contains at least 2 points. So that one really doesn't come into play very often.
No, I mean, it's just kind of a,
So the other one does.
if it's a line, it's got to have 2 points.
Yeah. So, and then if 2 lines intersect, the only way that 2 lines can intersect is exactly 1 point. Again, you can't have one straight line and a curved line that hits it in 2 places. They can only hit in 1 place. So 2 lines intersect, they intersect in 1 specific point. There's no other way that can happen. It is possible that they not intersect at all, but if they do intersect, they intersect in 1 point and exactly 1 point. So, okay. Kind of take it up a step in terms of dimension. If we have any 3 non-collinear points, then there exists exactly 1 plane that can go through those 3 non-collinear points. And again, you kind of have to think a little bit three-dimensionally here, but if we have 3 points that are not in the same line, non-collinear points, then only 1 plane can go through those 3 points. Exactly 1 plane.
Let's go back and let them see that again, I think. So here comes my 3 points. Notice they're not in a line. Pay attention to definition, and then through those, with those non-3 collinear points, you can make that plane. Pretty easy.
What would happen if they were in a line?
Then you have a line,
But how many planes go through a line?
an infinite amount.
Okay.
Because if your line's like this, you could wrap all the way around that sucker.
Yep. Can go it again at any angle.
Yep.
Kind of like the other question. So, all right. So those are just rules. You just need to know the concepts behind those rules.
Yeah, and really, guys, we're just going to take this in class tomorrow, and then you're going to apply it to different ideas.
Different diagrams
Yeah.
and so on.
Yep. So, well, like I said, you can take these and say, oh, because I know that through any 2 points there exists exactly 1 line, I can say this, kind of an idea.
Right.
Okay?
All right.
There we go. All right, so postulates 9 through 11. Number 9 says a plane contains at least 3 non-collinear points. So if we have a plane there, this time we've got the plane already there. If we were to put points in there, if we wanted to put just 3 points in there, guys, we would want to make those non-collinear. Now, 2 out of those 3 are going to be collinear, but we just kind of pull that third one off to the side so that way it's not on that line. Okay, so that'll give us a plane. I mean,
It's kind of like that second one about the lines. It really doesn't come up. This one doesn't come up that often. It's the other one. The fact that you have to have at least 3 non-collinear points to make a plane comes up much more often than this. We really don't see this a whole lot.
no, I mean, if you get one, you get the other.
Yeah.
So.
Yeah.
And then number 10 is if 2 points lie in a plane, then the line containing them lies in the plane. So watch as first here's the plane. Okay, now we're just going to put 2 points in there. There's one, there's the other. Now if I draw a line through those 2 points, it's kind of like laying my pencil down on 2 points on a piece of paper. My pencil is going to lay on that plane as well as onto those 2 points, and it just, your line comes across right there. I mean,
If you try to think of the opposite of that, how could you possibly have 2 points on a plane and have a line go through those 2 points but not be in the plane?
Yeah.
That just happen.
It just won't happen.
Yeah.
And then number 11, if 2 planes intersect, then their intersection is a line. Kind of, we already talked about this. I mean, just remember, guys, if you look at the ceiling of your room and where the wall meets, you kind of see that crease right there. That's where those 2 planes are meeting, and they're making a line. So this is kind of a review one for you. We're just now formally, I guess, defining it as a postulate, that we just kind of understand that that's what's going to happen. Okay?
Yeah.
And I think that's it.
Well, there's
Below the diagram, yeah. So this is a little bit harder to draw on your notes.
Yeah.
But if you draw a parallelogram vertical and then a parallelogram going horizontal and then kind of connect a line right between the 2 of those, that's basically all it is.
So it's really all this section is just these rules, and again, that's all they are. And so we just need to work with these to the point where we get them pretty much memorized, and again, not necessarily word for word, but the concepts behind them we need to know. Okay? So in class tomorrow, we'll look at some questions and problems dealing with these. So we'll see you there.